Hey guys, welcome to video for the day 3. Today we're going to talk about exploring our exponential functions. And remember, we have both growth and decay, so we're going to explore what that looks like more today. So recall that we've talked about both linear functions and exponential functions so far. The general equation for a linear function is y equals ax plus b. And we can write that in function notation by writing it as f of x equals ax plus b. Remembering that f of x is a fancy way of saying y equals, but they mean the same thing. What does the a stand for? The a stands for slope, and the b stands for the y-intercept. We have exponential functions with the general equation y equals ab to the x power, which can be written in function notation similarly by replacing the y with the f of x equals, and then ab to the x, just like the general equation. And just recall that the variable is always going to be the exponent for an exponential function. So I'll often say x exponent is exponential. What does the a, b, and x stand for? The a stands for the initial value, or remember that can also be the starting value. B is your growth factor, and x refers to time, usually, unless it's otherwise defined in the question. So exponential functions are able to have both a positive or a negative rate of change. Positive rate of change is called an exponential growth. When the b is converted to a percent, it is over 100%. So we describe as a growth of x percent. So that's however much over 100% that is. So if say it's 108%, that's a growth of 8%. It's gained 8%. Negative rate of change is called an exponential decay. And this is when the b number is converted to a percent. It is under 100%. So this is described as a decay of x percent being however much under 100% we have. So for example, if say it's the b number is converted to 75%, then we've lost 25%. So that's described as a decay of 25%, because 75% is 25% away from 100%. Okay, we'll talk about that more examples coming up. Okay, so when we look at our graphs, so back to linear functions, on the left side here, the graph is this graph shown here. This is a graph of a positive line shown increasing from left to right. The next example below that for the lines, this is a graph of a negative line, and it is decreasing from left to right. Now looking at these exponentials, if I look at this first one, I'm starting up all the way up here, and I'm going down. My y values are going down. So this is a graph of an exponential decay as it is decreasing from left to right. The next one, if we look at our values, they're going up. This is a graph of an exponential growth, and it is increasing from left to right. Okay, so for these next ones, we want to identify the following equations as either linear or exponential. So try to think to yourself, what is it before I answer it? So if I look at this first one, f of x equals 3 raised to the x power plus 2. Well, what do you think it would be? Well, as soon as I see the x is an exponent, I know that this is exponential. Okay, part B, we have 2y equals negative 5x plus 1. Well, the first thing I notice is it's not in y equals. I could get it into y equals by dividing them all by 2, but this is an equation, and I can see that even if I did do that and I got it into y equals, I would have the negative 5 halves x plus 1 half. Either way, this is going to be linear because it doesn't have the x as an exponent. It has a constant rate of change. Okay, the next one, y equals 7. So what do you, hopefully you thought about it. I think that it's linear because even though this is a special kind of linear function, it's a horizontal since it's just y equals, remember that little three-letter word hoy, but there's no x exponent, it's not exponential. The next one, I see the x is an exponent. I have some big numbers here, 16,332, and then the 1.052 or 52 thousandths raised to the x power. That is an exponential. So remember, you're always looking for what in there does it look like. Is it more like a linear function for the equations, or is it in the form of the ab to the x power to make it exponential? Okay, 2 through 5. We want to do two things in these questions. We want to first state the initial value. So remember, when we think of an exponential equation, y equals ab to the x power, we're looking for the a number, the number that's without the x's exponent. Then we want to convert b to a percent and state whether the function represents a growth or decay. Okay, so if I look at this first example here, c of t equals 100, that's my a, so that's going to be my initial value. So my initial value is 100. Then they said to change my b number to a percent. So 0.75, if I change that to a percent, that's 75%. So since that's 75%, that's less than 100%, so that means it's a decay. How much is it decaying? This is the example I talked about earlier. It's 25% away from 100, so it's decaying 25%. Okay, question number 3. So we have p of n equals 40. There's my initial value. And then the b, I have my b is 1.80, so if I convert that to a percent, it's 180%. So since it's over 100%, that tells me that this is a growth. And how much away from 100% is it? It's 80% more than 100%. So it's growing 80%. Okay, number 4, we have the a. Remember, that's the number by itself. So that's the 10,000. And then I look at my b value, the 1.02. 1.02 is equivalent to 102%. So that tells me that I have a growth, and it's growing. How much more than 100 is that? That's 2% more. So it's a growth of 2%. All right, next one. So the a, the number by itself, is the 50. And then the b, the factor, growth or decay factor here is 0.1. So what is that as a percent? That is 10%. So if it's only 10%, that means that it's decaying. How much away from 100% is 10%? 90%. So it's decaying 90%. Okay. Number 6, we're going to translate the following into an exponential function and interpret what the b number represents. Initial value of 525. So that's our a value. Grows at a rate of 20% each year for x number of years. So here I have all my pieces. I'm going to write down that exponential formula again up top here. We're going to keep coming back to that. So in place of our initial value, in the context of this question, the initial value is 525. So instead of putting the a, I'm going to put the 525. You could put parentheses around it, but you don't have to because it's the only one so far. But I am going to put parentheses around the b value. Okay, so it's growing 20%. So that means we're starting with the 100%, 1, and we're adding 20%, so 0.20. So 1 plus 0.20 is where that comes from, raised to the x power. And then we could rewrite that by combining the 1 plus the 0.20 to write it as 1.20. So this becomes 525 times 1.20, 1 in 20 hundredths or 2/10, raised to the x power. Now I'm just going to go over off to the side to show more about what I did to get the 1 plus 0.20. I knew over here it was 20%. So we could think of it all as percents first. This is up to you. You could think of, okay, well, it's 20%. And then what is that? What does that mean if it's growing 20%? It's starting at 100 and it's growing 20 more than that, so that becomes 120%. So maybe this is easier for you to say, okay, well, I know since it was growing 20%, that means that it was 100% plus my 20%. That's what I wrote over in this first line as a decimal. 100% changed to a decimal. 1 plus 20% as a decimal is 0.20. So this is the equivalent of what I wrote as a percent over here. Then I would need to take this 120% and convert it to a decimal to put it into my equation. So 1.20 is equivalent to 120%. So either way is fine. This is how we find the B value. Either you write it off to the side as percents, or maybe you can do what I did where I put it as a decimal right away. It's completely up to you. I think that this helps identify where these numbers come from. Okay, the next one, the initial value of 525. So again, they're telling us what we're starting with. That's my A value. It's again increasing by 3% each year for X years. So similar to the first one, we're going to start off with the Y equals 525. And then I'm going to need to find the B value. So if you want to off to the side, you can say, okay, well, it's 100% and it's increasing, so that's adding 3%. So 100% plus 3% is 103%. And then I can say, okay, well, 103% is the same as 1.03 as a decimal. So that's my B value. So if you can do that, then fine. You would now take the B and put it right in for the B in the original equation that I was trying to write. Or if you want to do the decimal that I was saying, maybe you feel like you already know the decimal, you could put the 1 plus 0.03 raised to the x power, and then convert that by adding the 1 plus 0.03, and your answer will look the same as what we would have had automatically from writing the percent over here. I knew that the B value was 1.03, so maybe you just put it in there right away. So it's up to you which way makes the most sense. We get the same answer either way. Okay, on to the next one. We're starting off with an initial value of 525. Now we're decaying at a rate of 25% each year for X years. So I'm going to start off with plugging in the initial value, and I'm going to stop there. I'm going to write off to the side this time, again, that we're starting off with 100%, but this time we're losing 25%. So it decays at a rate of 25%. So I'm losing 25% each year. So what does that mean? That means that the amount that we have is 75%, because 100% minus 25% is 75%, which is 0.75 as a decimal when we convert the percent to a decimal. Remember, that's moving the decimal place 2 places to the left, and that would be my B value. So we had 100% minus the 25% to find the B value. So if you do it that way, like I said, you don't even have to have that 1 plus step that I wrote in the previous one. If you're going to write the percents off to the side, then you can now come over and write the 0.75 in place of the B value. And then you'll have your answer right away. So that would be if you write the percent off to the side. Now, if you think that you can just write the decimal and not have the percent, then maybe you can, and you would write the Y equals, like I was doing in the previous, and you would have the initial, the 525, and then you would say, okay, well, 100% is 1, but I need to take away that it's decaying 25%, which would be 0.25 raised to the x power. You would get the same thing either way, so it's really just which one makes more sense. Do you like converting them to decimals and dealing with the decimals, or is it easier to think about the percents making it a percent and changing it to a decimal to put in place of b. Either one is fine. Okay, one more. The initial value is 525, decreases by 30% each year for X years. I'm actually going to leave this one and ask you to try this one on your own. But I highlighted all your key information to give you a start on that. Okay, so more application word problem information. We're going to need to identify the type of function. So based on the words, do we find out that it's a linear and going to be in the form of ax plus b? Or is it exponential, needing to be in the form y equals ab to the x power? If it's exponential, you'll need to determine the a number, so the initial or the principal amount or what we start at, then the b number as a growth over 100% or a decay under 100%. If a growth over 100%, you need to convert the percent to a decimal to be used in the problem and put in place of the b. If it's a decay under 100%, determine how much it is under 100, and this will be the new percent to then convert to a decimal to then be used in the problem in place of our b in the equation. Okay, so we're going to try one together. So we have Ryan who bought a new computer for $2,100. The value of the computer is decreasing by 40% each year. Write an equation to model the value v of Ryan's computer as a function of time in years t to the nearest dollar. What will the computer be worth in 3 years? So before I can find what it'll be worth in 3 years, I want to just start by writing an equation. So since it's decreasing by 40%, that means we're starting with 100% and we're decreasing 40%. We're losing 40%. That means the computer is only worth 60% of the initial value. So now I have the 60%. I can change that to a decimal to be 0.60. That's my new b number. So now I can go take that and put it into my exponential equation. Y equals, a is the initial value, so in place of a I'm going to put the 2,100. The b value, like I just found, is 0.60 now because it's losing 40%, so 60% of the original. And we're going to raise it to the t power. And I just realized I didn't write v equals. Remember they said in the problem I had to use v, so replace your y equals with a v. So write an equation to model v, the value of Ryan's computer, as a function of time, so v of t, instead of y equals. So we had to change that to v of t equals 2,100 times the 0.60 to the t power, because they told me I had to use v and t and write it as a function. Now that I've written the function, I can determine the worth in 3 years. So now instead of being v of t, it's v of 3 because it's 3 years after the computer was purchased. So 2,100 times 0.60 and then raised to the third power. Now it's a job for the calculator. So you can go ahead and put that in your calculator using the 3 for the exponent. So you can just put it on the regular screen, 2,100 parentheses, 0.60 close parentheses, raised to the third power. And we get 453.60. But they asked me to determine the value after the 3 years to the nearest dollar, like I highlighted up there. So my answer is going to be $454, since that's rounded to the nearest dollar from my answer. So my final answer is the 454. Okay, you're going to try question number 8 on your own, and we'll talk about this more together. Have a great day.